Okay, so I decided
to
do this challenge from a very objective perspective. First, I started off just by having it go a random distance because it was easier for me to test. But today, when I came back to it, I decided to properly implement a function so that it would automatically calculate the encoder count required to go 2 feet forward. And I decided to set up a for loop that kept track of how many times it's already moved and used the count of how many times it's moved to determine how many feet and multiplied that by the encoder count. And then I went ahead and got annoyed at the fact that it wasn't moving straight, so I decided to try using PID and was reminded that the robot CPID does not work. So then in my rage, I remembered that a while back I coded my own custom version of PID. I loaded it up, had to move a few things around because I coded it a while ago, and it never quite worked properly. And it works by keeping track of whatever I set the motor values to on the previous program cycle and modifying it based on whatever the current distance of each separate motor is. And then sets both of the motors at the same time. And it's even calibrated in such a way that it will automatically adjust when going forward or backwards, using absolute values and various other methods. Okay, well, if we go over there now, I'll actually show you the program in action.
And then it stops after it reaches like over 18 it stops. And it's not showing anything.
And start. It's not perfect, but it works better than what Robot C gave me.
So explain it one more time, is that it's not using any sensors to know where the lines are?
It doesn't use any of the sensors mounted on the front of the robot. It does know of their presence right now, but it is not set up to use them. It is just using encoders mounted to the back of the motors.
And you calculated, you made it so the robot could actually calculate the values of the distances between the lines.
Yes, the robot's calculating all the distances. I just told it, here's how many inches you need to go. Here's the radius of the wheel, which I told it to automatically convert to the diameter. Actually, the circumference, not the diameter.
Could you just show us in the code real quick?
Yeah, I can show you that. I just gotta get rid of my run window. It's this little line right here. I defined an integer and told it to round down because it can only accept integer values for encoder counts. Gave it the resolution per rotation of the motor, the distance I wanted it to go, and then I divided that by the circumference of the wheels, which is 4 pi in this case. And then on each cycle, it multiplies the current count by this value.
Great job. You were able to solve that challenge on your own, right?
Yeah, all of this is hand-coded myself with minimal input from tutorials, tools, knowledge that I've gained. And when it returns, I don't actually have it doing any math. I just say, bring the encoder back to 0. Because I reset it at the starting point.
Great job, Ben.